All right. Thank you all for staying all the way. So for this section, we have a panel discussion. And in contrast to yesterday, where we had reports first, and then we had panel discussion, but we had to keep it a little bit short because we had to be out of here. So we're going to start with a panel discussion, and then we'll let the leads of each of the groups to basically hassle them. So that's the idea. So we would like to actually have an exchange about what you discussed in different groups, in different rooms. And so please bring up that perspective, talk to the panelists. So I'll ask Jakob to join us on the panel, as well as Patrick Minot from Amaranth Foundation, Scott. And Carl is going to moderate them, so you can join on the panel with them, please. So I won't say anything. I'll be just sitting there. But let's say we want to have the initial part of the conversation, and then we'll open up the floor to discussions, questions, and so on and so forth.
Okay. Well, I was just asked to moderate this about 1 minute ago, so I'm well prepared. Yeah, so I think we're going to talk about models and foundation models, whatever that means, and how do we prepare data for foundation models? How do we prepare ourselves for the world of foundation models in neuroscience? Remember, we're talking here about, this meeting is about dynamic brain data, neurophysiology. How do we package data? What would we think? What should we think about as neuroscientists, right, in preparing for kind of this new world, however that might look? How do we acquire data? What kind of data hygiene do we have to do? Those are the kinds of questions I'd love for you to touch on. How do we share the data, prepare the data for sharing? How careful do we actually have to be about data quality? We had this discussion yesterday a little bit, right? Or are the kind of these transformer methods ultimately pretty good at regularization so that the junk kind of disappears ultimately and stops polluting whatever comes out the other side? And I encourage you all to engage in additional questions, but I want to just open it up. And the other thing, the last thing that sort of come to my mind as I've listened to the talks today and discussed with some of you and in other meetings, how do we, there's of course a lot of methods that are coming online. It's moving extremely rapidly. Maybe you can give us a little bit of advice. How do we kind of navigate this fire hose of models? And how do we learn, vetting these things in the context of a neuroscience kind of experiment is a heavy lift, right? And how do we kind of find out what the fruitful approaches, how we learn about what the fruitful approaches are and don't get stuck in dead ends? Is there some kind of place or possibility for these models and machine learning approaches to be vetted, right, before we kind of sort of dive in? Is there some kind of leaderboard, let's say for dimensionality reduction, for example, right? Is there other some sort of metrics that everybody agrees on? And similar for other kinds of modeling endeavors. Everybody shows that in their talks, but is there some agreement about, what the right parameters are and who the winners are, so that we kind of sort of start with the most promising approaches? That's a little bit random, all of it, I understand, but let our panelists speak, and maybe 5 minutes each as yesterday, and then we'll open it up to everybody else.
I feel like I should go first here now. Just down the line, how about? So I'm Scott, for anybody who I didn't meet this morning. So I guess maybe one place to start with this question, and something that came up in our conversations in the small group, was at some point about 10 minutes in, somebody raised their hand and said, wait a second, what's a foundation model? And I think that that's something that maybe we could, there is some debate as to what constitutes a foundation model. I can give one perspective on that, but I don't claim it to be the only answer to this question. I think one of the things that makes a model foundational as opposed to just a really big model is that typically foundation models are distinguished by being trained on extremely broad data sets. Basically every piece of data that you think is relevant that you can get your hand on, and the canonical examples in AI and machine learning are vision models, large language models, things that are trained on every image on the internet or every bit of text you can scrape from the internet. So that's one of the hallmarks. I think another hallmark of a foundation model is that it's something that's quite versatile, something that can be trained and solved many different tasks, and maybe during training it's not necessarily trying to solve any particular task. It's doing something quite general, like learning to predict the word that comes in the middle of a sentence based on the words that came before and after. And then finally, if it's truly a foundation model, it should be a foundation for something. What is it that it's gonna allow us to do that we couldn't do before? Well, I think ideally a foundation model is something that we should be able to build on to solve specific tasks of interest with minimal fine-tuning, minimal extra amounts of data above and beyond what was already available during the pre-training stage. So I think those are at least three defining characteristics, and I'd be very curious maybe as we go down the line to hear if anybody would alter that definition or add to it. In the context of neuroscience, I think an important question for us with that in mind is, what is it that we would like some foundational model for neuroscience to be able to help us to achieve? And when I think about the types of tasks that come up in neural data analysis, I broadly categorize them into a couple of different groups. I think there are lots of problems around signal extraction. We spend a lot of time talking about spike sorting in our group. That may seem like a strange topic to get onto when talking about foundation models, but we'll come back to that in a sec. But I think there are problems of signal extraction that dominate a lot of our attention. They're certainly important here at the Allen. I think there's a second group of questions that are about encoding and decoding. How do we predict neural responses to some sensory input? How do we decode what types of behavior might be produced as a result of some measured neural activity? And then I think there's a third category of problems, which are ones that I spend a lot of time thinking about in my own research, about more discovery and unsupervised learning. Given some high-dimensional neural time series, can we identify low-dimensional states or structure embedded in that high-dimensional signal that might be telling of what computations this circuit is trying to perform? And I think different types of problems may lend themselves better to foundation model type of work. I think especially those first two, where oftentimes there's a clear type of prediction task. Let's pick encoding, decoding. I think this is where, Patrick, I'm sure you'll tell us about some of your work in this domain. Building foundation models for brain-computer interfaces seems like a quite promising first step in this direction, because there's a very